Today we are on page 7 of our Chapter 3 notes packet, section 3.7, which is rationalizing a denominator. To rationalize a denominator containing a radical means to rewrite the fraction as an equivalent fraction with a rational denominator. That is, there's no radical in the denominator. Radicals may appear as part of a fraction. It is fine to leave a radical in the numerator of a fraction, but it is poor mathematical form to leave a radical in the denominator. Before going on, keep in mind that it is always a valid option to multiply by something equivalent to 1. For example, if we have the square root of 2 over 3, this fraction is in proper form and may be left as it is. A radical in the numerator is fine, but a radical in the denominator is not. So the fraction 2 over the square root of 3, this fraction is not in proper form and must have its denominator rationalized. This is square root of 3 in the denominator is not a rational number. It's irrational. What could the square root of 3 be multiplied by so that it would no longer be a radical? We can multiply by the square root of 3. Because the square root of 3 times the square root of 3 would result in 9. The fraction with the square root of 3 in its denominator, which is equivalent to 1, is square root of 3 over square root of 3. Right? The square root of 3 over the square root of 3 is equivalent to 1. So if we take our fraction 2 over the square root of 3 and multiply by 1 in the form of square root of 3 over square root of 3, we get 2 square root of 3 over the square root of 9, and the square root of 9 is 3. So that results in 2 square root of 3 over 3. So now this is a rational fraction. The denominator is a rational number. If the denominator is a monomial, we multiply by 1 in the form of square root of a over square root of a, then simplify the result. For example, we have 5 over the square root of 3. Again, we have to rationalize the denominator, so we'll multiply by square root of 3 over square root of 3, because that will bring us up to square root of 9, and 9 is a perfect square, and we can take its square root. So again, a radical times itself more or less undoes the square root. So square root of 3 times square root of 3 is 3. Can this fraction be simplified? No. So this is our final answer. Now 7 over the square root of 12, we could multiply by 1 in the form of square root of 12 over the square root of 12, but we're going to be working with some larger numbers. So let's take something smaller, okay? What's the smallest perfect square that 12 will divide into? Be 36, right? So we can simply multiply by square root of 3 over square root of 3. And we'll get 7 square root of 3 over the square root of 36, and the square root of 36 is 6. So this is 7 square root of 3 over 6. And our fraction cannot reduce, so that's our final answer. Number 3, we have 2 square root of 5 over the square root of 8. Again, let's focus on the denominator here. We want to bring this up to a perfect square, so why not multiply by square root of 2 over square root of 2, bringing it up to the square root of 16. Square root of 5 times square root of 2 is square root of 10. Square root of 8 times square root of 2 is square root of 16. But this is a perfect square, so that's 2 square root of 10 over 4. Can this fraction reduce? Yes, the 2 and the 4 reduce. So we have a final answer of square root of 10 over 2. Okay, so if you would stop the video, try the next three. You want to rewrite each fraction in proper form, that is, rationalize the denominator. So pause the video. Okay, 5 divided by the square root of 2. We need to rationalize this denominator, so we'll bring it up to the square root of 4 by multiplying by 1 in the form of square root of 2 over square root of 2. So we have 5 square root of 2 over 2. This fraction doesn't simplify, so that's our final answer. B, we have 55 divided by the square root of 11. We want to bring the denominator up to a perfect square, so we'll multiply by 1 in the form of square root of 11 over square root of 11. So we have 55 square root of 11. Square root of 11 times square root of 11 is 11. Can this fraction reduce? Yes. The 55 and the 11 can reduce to 5 and 1. So our final answer is 5 square root of 11. Next, C, we have 2 square root of 3 over 7 square root of 5. Sorry, 7 square root of 15. There is more than one approach here. You could reduce the radicals. Let's say we don't do that, and let's say we bring square root of 15 up to a perfect square and multiply by 1 in the form of square root of 15 over square root of 15. 2 square root of 3 times the square root of 15 is the square root of 45. 7 times 15. We'll simplify. Square root of 45, that's 9 times 5, we're thinking. And the square root of 9 is 3. So we end up with 2 times 3 times the square root of 5 over 7 times 15. And instead of multiplying, let me reduce first, right? The 3 and the 15 reduce, because this is all multiplication here. So we can divide out common factors. Now our numerator is 2 square root of 5, and our denominator is 7 times 5, which is 35. Next, page 8. If the denominator is a binomial multiplied by 1 in the form of what's called the conjugate of the denominator over conjugate of denominator. The conjugate of a binomial is is identical to it, but with the opposite sign in the middle. For example, consider the binomial 3 minus the square root of 5. This binomial has a conjugate. It is 3 plus the square root of 5. To multiply binomials, we use FOIL. So let's FOIL. 3 minus the square root of 5 times 3 plus the square root of 5. First terms, 3 times 3, 9. Outside, 3 times the square root of 5, 3 square root of 5. Inside, negative square root of 5 times 3, negative 3 square root of 5. And out, and last, negative square root of 5 times positive square root of 5 is negative square root of 25, which is simply minus 5. Combine like terms, 9 minus 5 is 4, and positive 3 square root of 5 and negative 3 square root of 5 is 0. So our end result when foiling these two binomials is a rational number 4. 4 is a rational number, right? It does not contain a radical. What happened to the radical parts of the product? The radical parts here combined to be 0. They combine to be 0. Let's go back to conjugate. The conjugate of 4 subtract square root of 6 is going to be 4 plus the square root of 6. The conjugate of the square root of 10 plus 7, again, these two terms remain, square root of 10 and 7, and you just change the operation between them. The plus goes to minus. So now we want to rationalize denominators by multiplying by 1 in the form of conjugate of denominator over conjugate of denominator. That's when our denominator is a binomial. Please note, if a numerator is a numerical monomial, wait before you distribute. All right, so we have 3 over 2 plus the square root of 5. We need to rationalize this denominator, right? It contains a radical. Cannot remain that way. So we multiply by the conjugate of the denominator over conjugate of denominator. The conjugate of 2 plus the square root of 5 is 2 minus the square root of 5. I'm going to hold off on distributing in the numerator. But the denominator, when we FOIL, okay, because these are conjugates, the end result is going to be the product of the first terms. 2 times 2 is 4. Your outside and inside terms are going to combine to be 0. So then we're left with the product of the last terms. Square root of 5 times negative square root of 5 is going to be minus 5. 4 minus 5, that can combine, that's negative 1. And now if I distribute, that's going to be 6 minus 3 square root of 5 over negative 1. Or, if I divide each by negative 1, this would be negative 6 plus 3 square root of 5. So again, we no longer have a radical as a denominator. The next one, 2 plus the square root of 3 over 3 minus the square root of 10. Focus on the denominator. We have to rationalize that. It's a binomial, so we multiply by the conjugate of the denominator. What is the conjugate of this denominator? It's 3 plus the square root of 10. So we're multiplying by 1 in the form of 3 plus the square root of 10 over 3 plus the square root of 10. Now we'll have to FOIL. If you need to, put parentheses around these. FOILing the numerator, 2 times 3 is 6. Outside, 2 times the square root of 10 is 2 square root of 10. Inside, square root of 3 times 3 is 3 square root of 3. And last, square root of 3 times the square root of 10 is square root of 30. Now, since the denominators are conjugates, FOILing these, our end result is going to be the product of the first terms, 3 times 3, which is 9, and then the product of the last. Negative square root of 10 times positive square root of 10 is negative 10, right? It's negative square root of 100, which is 10. So again, we end up with a negative 1 down in the denominator. I don't see any like terms here in the numerator, so everything stays. The square root of 30 may not be simplified, so everything stays as is. This is going to be 6 plus 2 square root of 10 plus 3 square root of 3 plus the square root of 30 all over negative 1. Or let's just divide each term by negative 1, so we have negative 6 minus 2 square root of 10 minus 3 square root of 3 minus the square root of 30. And rationalizing our denominator here, we multiply by the conjugate. The conjugate of square root of 6 minus 2 is the square root of 6 plus 2. So we're multiplying by 1 in the form of square root of 6 plus 2 over square root of 6 plus 2. Since this is a numerical monomial, I'll hold off on actually distributing it. So I'll write this as 8 times the square root of 6 plus 2 in parentheses. Foiling, our end result, is going to be the square root of 6 times square root of 6, which is 6. And then the last term is negative 2 times positive 2 is negative 4. 6 minus 4 is 2. And now, can we simplify this fraction? Yes, the 8 and the 2 reduce. 2 goes into 8 4 times, 2 into 2 once. So we have 4 times the square root of 6 plus 2, which we may leave it like this, or we can distribute, get 4 square root of 6 plus 8. Now on the next page, page 9, all right, try those first 4 problems on page 9. Right. Again, pause the video, try them on your own, and then start up the video again to check. We have 4 over the square root of 18. I want to bring this denominator up to a perfect square, so I'll multiply by 2 to bring it up to 36, meaning the square root of 2. So I'll multiply by 1 in the form of square root of 2 over square root of 2. This would be 4 square root of 2 over the square root of 36. So 4 square root of 2, the square root of 36 is 6. Okay, we've rationalized the denominator. Can we simplify the fraction? Yes. The 4 and the 6 reduce. So our final answer is 2 square root of 2 over 3. Number 2, I want to bring the denominator square root of 8 up to a perfect square, 16. So we'll multiply by the square root of 2 over square root of 2. It's the square root of 2 over square root of 16, which is a perfect square, 4. Square root of 2 over 4. Number 3, our denominator is a binomial, so we'll multiply by the conjugate of 2 minus the square root of 5, which is going to be 2 plus the square root of 5. So we're multiplying by 1 in the form of 2 plus the square root of 5 over 2 plus the square root of 5. I'll hold off and just write this as 4 times 2 plus the square root of 5. When we FOIL or multiply these denominators, since they're conjugates, the end result is going to be the product of the first terms. 2 times 2 is 4. And then the product of the last. Negative square root of 5 times positive square root of 5 is minus 5. So 4 minus 5 equals negative 1. And I'll just bring the negative up into the numerator. So we have negative 4 times 2 plus the square root of 5. This could be an answer, or you could distribute and give negative 8 minus 4 square root of 5. And number 4, again, we need to rationalize the denominator. The conjugate of 2 minus the square root of 3 is 2 plus the square root of 3. So we're multiplying by 1 in the form of 2 plus the square root of 3 times 2 plus the square root of 3. We need to FOIL our numerator. First terms, 2 times 2 is 4. Outside, 2 times square root of 3 is 2 square root of 3. Inside, square root of 3 times 2 is 2 square root of 3. And last, square root of 3 times square root of 3 is 3. Denominator, since they're conjugates, the end result would be the product of the first terms, 2 times 2, 4. And the product of the last terms, negative square root of 3 times positive square root of 3 is negative 3. 4 minus 3 is 1. Combining like terms in the numerator, 4 and 3 is 7. And 2 square root of 3 plus 2 square root of 3 is 4 square root of 3. All over 1. We should have just left that as simply 7 plus 4 square root of 3. And this concludes our video for tonight.